Picture a university lecture hall. The professor steps away from the chalkboard, leaving behind a sprawling labyrinth of calculus, and asks for a volunteer to solve the final piece in front of the class. Two distinct things happen. One student immediately raises their hand, eager to tackle the problem in front of 50 peers. Another student slinks down in their chair and breaks eye contact, choosing to work on a much simpler problem at their desk. The standard way to read this room is to categorize learning as a binary. We assume the first student is trying, while the second student is not. But both students are making calculated decisions. They are moving through the same environment, yet they are being steered by an invisible psychological engine that dictates how they respond to pressure. Unless we reverse engineer how that engine operates, we fail to see how human beings actually learn. The first layer of that engine is the source of the drive. For our volunteer, the math itself might be the reward. The act of untangling a tough equation provides its own satisfaction. This is intrinsic motivation, the desire to do the work because the work is inherently interesting. But the same behavior could be fueled by extrinsic motivation. In this case, the drive relies on outside factors, like the expectation of demanding parents or the hope of impressing a romantic interest. This makes extrinsic motivation fragile. Anchored to a specific external reward, the link shatters when that factor disappears. Intrinsic motivation follows a different logic. Finding satisfaction within the task, the drive stays intact even as external circumstances shift. This reveals a primary rule. If a change in outside rewards or social pressure causes your drive to vanish, that motivation was never truly yours. The second layer is the direction of the drive, where the brain calculates the trade-off between achievement and avoidance. For the student at the chalkboard, the potential for a public win outweighs the risk of public embarrassment. They are operating on an achievement strategy, where the brain prioritizes gain over potential loss. The student in the back row is focused on an avoidance strategy. Their primary goal is to escape failure. In their calculation, the safety of remaining unnoticed is more valuable than any possible reward for being right. We all carry a different internal scale. Identical situations are weighed differently depending on an individual's profile, meaning two people in the same room can view the same math problem as either a golden opportunity or a dangerous threat. Because these risk assessment profiles are deeply ingrained, the same classroom will always produce these opposite behaviors. Consider a more paradoxical case: the student who constantly interrupts the professor to ask difficult questions. They persist even when it's clear they are annoying everyone in the room. Eventually, the professor grows resentful of the interruptions. This friction starts to affect the student's grades, as the instructor marks their work more harshly. By every external metric, the student is failing. We can explain this behavior by looking at the difference between mastery and performance. The student is oriented toward mastery, the acquisition of raw knowledge. They are indifferent to performance, which is the external metric of the grade. They will sacrifice their GPA and their social standing if it means getting the information they need. It is a reminder that true mastery can look like failure when it is viewed through a system that only values performance metrics. If we zoom out from the classroom, we find a broader principle at play. No human activity occurs without an underlying motive, even if that motive is hidden from view. These motives are not random. They are expressions of deeper, non-negotiable needs. In the context of learning, those needs go all the way down to our biology. The engine of the classroom is ultimately powered by a hardwired imperative for curiosity. We can trace every action back through this model. The outer shell is the behavior we see. The middle layer is the psychological motive, but the pulsing core is the biological need to explore and understand. This hierarchy suggests that many of our educational structures are in conflict with our own nature. When we try to force learning through fear or grades, we are trying to override a system that has been refined over millions of years. Lasting education occurs when we stop trying to manipulate behavior and instead focus on the core, feeding the biological curiosity we were born with.